the next question is, what happens if the call terminates in the panel, but it's coming from somewhere else? So in this example, we've actually placed a call from a line in the number 5 crossbar to a line in the panel. So we're going to start tracing it in the panel, but then we're going to leave and we're going to go over to the number 5 crossbar. And now you're really going to get an idea for why it takes so long. Because tracing a call in the panel is easy compared to tracing it in the number 5 crossbar. You're about to see why. All right, so we called the same number, and we have, again, this selector is up with this brush tripped at about the 3/4 of the way up mark. So this is 5, 6, 7, 8. So what we want to do now is for final number 48, we need to go again back and see which incoming is actually trying to use this final. And this is going to be just like we did it before, where it's easy because we only have one incoming up, this one. And I can see that this brush is tripped. And again, this is the upper half of the 5000s group on these terminals here, which are going to get us to final frame number 7. These would all go to different final frames. But this group gets us to final 7, and here we are. But this time, the incoming is number 34. Right? Last time it was different. And if I look at my records, I can see that there is no incoming 34 that's served by this office. So that means the call is coming from somewhere else. Now, what I have to do is figure out who else in the museum or in the world, in the switching network, could be using incoming 34. So I wanted to take this time to point out that the real records are on my iPad. All right, so I don't necessarily have to keep paper records when I have spreadsheets like this that tell me, for instance, every phone number in the museum or every single interconnect in the museum and where it's coming from and where it's going. So if I look at this spreadsheet, I can tell that that incoming is being served by the number 5. So now we get to go over there and figure out where the call's coming from. When a call leaves the number 5 crossbar, it leaves on an outgoing trunk circuit. So there are frames and frames and frames of circuits just like this that handle calls that are leaving this switch and going somewhere else. So at this point, what would have happened in real life is the panel office would have called into the number 5 and said, hey, incoming selector so-and-so, I'm trying to do a trace on that. I need you to take a trace from here. Right? And they would talk and they would figure out, okay, one of these outgoing trunks is connected to incoming selector so-and-so in the panel office, and I just have to find which one it is. We can look at that through office records, but in the museum, the number 5 only has a few direct trunks to the panel office, so I could just look at them and tell you which one it is. It's this one here with the S1 relay off normal. This is another reason it's easy in the museum. In the real world, they wouldn't all be in one place, and they might not all be in the right state for me to do that, but it's this one with the S1 relay and the S relay off normal. You see they're both operated, they're both pushed that way. And that's trunk number 27. So this is 26, that's 27. So what we have to do now is go and check our office records, because I don't have this written down on my iPad. Here's the office records for the number 5. They're under, it's called an under glass bulletin because it's a bulletin that's under glass, or plastic in this case. And we have listed here all of our outgoing trunks, and we have the 2 of them for the panel office. Here's trunk number 27, and it terminates on FA73. Remember that, it's going to be important in a second. All right, back over to the switch frame. In the number 5 office, trunks terminate on the horizontal levels of the trunk link switches. So this is the trunk, that's a trunk, this is the trunk, that's a trunk, all the way up the switch, right? We said our trunk was FA73. So on crossbar switch number 7, that's the first digit, our trunk is going to be whoever is sitting on the 3rd horizontal up, which is that one right there. That's our call at that cross point there. You could see why this gets hard, because if you have 10 or 20 trunk link frames in the office, you have to know the exact frame and the exact cross point that will be serving that trunk. But I can see that, let me focus it. I can see that those cross points are closed at the 3rd level on switch 7 for FA, which is the left half of the crossbar switch, which, yeah. So that is my trunk. Now, what I have to do is trace this particular call through the crossbar network to determine which line is actually on this call. And you can imagine doing that when the switch is really busy and calls are going up and down constantly, and you're just trying to do this in this really loud, crazy room. It's a tough job. The crossbar network is complicated, and I'll throw this graphic up on the screen so you don't have to worry about staring at it with me. But if the trunks appear on the horizontals, they go out to the next stage on the verticals. So we were using vertical 0 on switch 7. Vertical 0 on switch 7 always connects to vertical 7 on switch 0 because it's because of the way the network fans out and interconnects. So vertical 7 on switch 0, sorry, vertical 0 on switch 7 is going to go to vertical 7 on switch 0. And here it is. So this is my call, and I need to figure out which of these cross points is active. It's this one right here. So horizontal 0, 1, 2, 3. And I'm going to write it down, because one of the things that's really hard about this for me is being insanely dyslexic. When I have numbers that flip or go opposite, or I have to go from a horizontal to a vertical and then transform that in my head, it's insane. I cannot remember it for the life of me. So if I don't write it down, by the time I stand up and walk away, it's gone. It doesn't matter how many times I've said it. I work in the most confusing museum on the planet. Okay, so we have traced it so far from the trunk circuit itself, right, to the trunk circuit's appearance on the trunk link frame, which is that right there. And these two switch frames have a specific way of linking together on the back. If you want to Google it, it's called a CLOS network, C-L-O-S. It's named after a guy, right? But each crossbar switch has a way of linking to every other crossbar switch, so that there's basically always a path through the network in a known pattern. And so what we've got is we're at the junction switch, which is the next step out, and we're at switch 0, vertical 7, horizontal 3, and we need to follow that to the line junctor to get close to the actual line that call came in on. So my line junctor switch is right here, and this is our next step. All right. I'm gonna say again that if this is all starting to seem really to you, don't feel bad, because it is. This crossbar is bonkers. And this is me who's worked on this machine and knows how it works. It's crazy. And if if just tracing it between one trunk link frame and one line link frame is hard-ish, or maybe a little confusing, just imagine aisles and aisles and aisles of these frames, all of which are interconnected to everything else, to each other. And then you start to get a sense of like just how complicated this machine can really get. But anyway, so we left our trunk link, and the trunk link horizontal connects to a similar numbered line link junctor vertical. So this half of the frame from here over, all of these are my line junctors, and they're connected to trunk junctors. So what I need to find is vertical number 3, and there it is. Somewhere on there, a cross point is connected. So here's vertical 3, and I'm looking at my cross points, and I see that those cross points right there are closed. That is vertical 3, horizontal 7. Now on my line link frame, between the junctors and the actual line links, there's that same inverting sort of relationship, where vertical 7 is going to connect somewhere on switch 7, right? So we have switch 0, 1, 2, 3, 4, 5, 6, 7, and one of these horizontals is correlated to that horizontal down there. Let me grab the ladder. Ah, here it is. Horizontal 0, because it's coming in from switch 0. So right where I'm shining my light, these cross points right here are closed. And it is this vertical that's closed. Right now, my finger is on the source of that phone call. It is this exact vertical bar that is my caller. Okay? So now, in order to move any further on, we have to talk about the layout of the line link frame. So what is this, right? All of my customers, whether they're originating a call or terminating a call, appear here. And the customers appear on the verticals. So my verticals are my customers, and my horizontals are my paths in or out for those customers. Now, when you and I look at this, we just see a stack of switches with 20 verticals across. But the system doesn't look at it that way. Okay? There is sort of a logical addressing that's happening here that isn't visible to us with our eyeballs, but is very, very visible to the switch in its internal circuitry and its understanding of the universe. So that is described by this laminated sheet here. Okay? This is a photograph of this exact line link frame. This last bit here is the junctors. So this isn't line link, this is junctors. And it's even weird to talk about it, but the frame is actually electrically split on this line right here. This last bit of equipment is not electrically line link frame. It is junctor frame. It just happens to be in the same metal frame unit, because why not? So the line link frame is split into horizontal switches. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's split into vertical groups, each containing 5 verticals. 1, 2, 3, 4, and 5. And then each vertical group is split into 5 files. 1, 2, 3, 4. So when we talk about a line location on this switch, we talk about it as frame number, vertical group, switch number, and vertical file in that group. So for example, here is frame number 00, 00 is this entire frame. Vertical group is 04, 1, 2, 3, 4. The next digit 2 is switch number 2, 1, 2, and then vertical file 3, 2, 3. That's how this machine understands its line link layout. Okay, that's its view of the universe. So what we have to do now is find for our subscriber, what is their address on this frame? What is their physical address? So the first two digits are easy, frame number 0. The next thing we're going to be looking for is which vertical group are they in? So they are right here, and down at the bottom of the frame, stenciled in black, if you follow this line all the way down, they're in vertical group 04. So the first 4 characters of their address are 0004, right? The next character is the switch number, 1, 2, 3, 4, 5, 6, 7. And it also says 7 right there, so I don't have to count every time. So they are 00, 04, 7, and then we're looking for the vertical file number, also stenciled right here, 1, 2, 3. So O is there, 1, 2, 3. That's my vertical that's connected to that horizontal that I showed you earlier. Okay? So their address on the frame is 000473. So remember that number, because now we have to go look at our office records. So I have this on my iPad as well, and you could see that for every line, these are all lines in the number 5 crossbar, we have the address on the line link frame right here. So all I would have to do is, since this is a spreadsheet, I could just sort by this column, right, and find 000473. It's right here. And if we take this and we go across, we can see that this is 2320013. That's the phone number that originated that call. And that line is right here. Just hung it up. The other thing that you'll see in that movie, The Slender Thread, is part of the troubleshooting takes place in a number 5 crossbar office. And it's actually the number 5 crossbar office in this building. Although that office is no longer here and it's not this one. But you'll see the switchman go to this test frame and then type up some numbers and run a test. And when he runs the test, a card drops, he looks at it and then walks away down through the switch room. And the test he does is called an MLV, or marker line verification test. And I think in the movie, that is supposed to be a little bit of Hollywood magic that says, the switch told me this, and I have to go look over here. But on our number 5 crossbar, I ran an MLV test. Let's just go ahead and run it on the number that we were playing with earlier, 0013. So Office A, 0013, MLV, and we'll request a trouble record, which we'll get right now. And interestingly, on the trouble record itself, there's no punchings that show me the originating line for that test. So it did not tell me where is that line at all on the switch. Kind of weird. What it did tell me is that, actually, let's back up a little bit, because now we got to talk about how this frame works. On an MLV test, your input is the last 4 of the phone number, so 0013 in Office A. And the second thing we have to input is what we think the actual address, physical address of the customer should be. So if you remember back from just a minute ago, it was frame 0, vertical group 4, horizontal 7, vertical file 3. And we punch that up on the thing, and we get a green light for marker line verification match. That means the physical address of the line and the line number that I put here are correct. But if it's wrong, we get an MLVF for marker line verification fail, and it'll spit out a ticket if I ask it to. But interestingly, on the ticket, it doesn't tell me what the right answer is. So, couldn't find any documentation about why that's the case. Talked to Astrid about it, and Astrid mentioned that it's probably because your physical files, your office records, are your literal source of truth, not what's wired into the machine. So it's really no good to ask the machine, what do you think of this? Like, where do you think this customer is? It's either what the paper says, in which case you'll get a match, or it's what the paper doesn't say and you'll get a fail. Right? That's how this is apparently supposed to work. There's one more thing I want to point out to you, and it's over here. Here. All of these demonstrations have been about what it's like to trace a call that's already in progress, right? But what happens if you get a nuisance caller that maybe every time this nuisance caller dials a person, we want to trace them, right? Here's how that's done. This is a cute little gizmo. You can get down here and look at this. This is a cute little gizmo made by some other company. It's the IV450 number group trap circuit. Very cool. And it tells you that the red lead goes on the subscriber's number, the white lead goes on the LLF punching, and the black lead goes on this XLL punching. So, got a magnet on the back, stick it on the side of the frame, wire this thing up as required. So this is the subscriber's line, this is their LLF punching, and somewhere in here there's an XLL punching. And every time this subscriber gets a call, the machine will drop a card. And that card should say who originated that call. So I've never been able to get this thing to work. Then again, I haven't tried really hard, but it's cool. And it's a possibility for how you could trace a call. Also, hey, trouble recorder's working. Bye.